طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions yes يا شباب before we proceed? Any questions before we proceed? Okay, so this is what we have done so far in chapter 6. We looked at three different rules. We started with the product rule. We saw some examples. Then we took the sum rule, and we took some examples, and we took some more complex examples where we cannot use basically one of them. We have to use both of them. And then we took some examples on the subtraction. Okay, we took some examples on the subtraction. So now what we will do is, after the product with sum with subtraction, like division, huh? So let's see what is this division rule. Okay, so let's assume that a task can be done using a procedure that can be carried out in n ways. However, for every way W, there are exactly D from the n ways that are equivalent to that W, or that represent that way. Okay, that represent that way. In that case, what do we conclude? We basically conclude that there are n over d ways to do this task. There are n over d ways to do this task. Now, it could be a little bit confusing right now. So maybe the best thing to do is let's take an example. Let's try to apply this rule on this example. So what is the example? Well, the question is, how many different ways are there to seat 4 people around a circular table where 2 seatings are considered the same when each person has the same left neighbor and the same right neighbor? Has the same left neighbor and the same right neighbor. For now, let us forget about this last constraint, that 2 seatings are considered the same when each person has the same left neighbor and the same right neighbor. Let's not, for now, not consider this constraint. And let's look at the problem in general. So basically, what do I have? I have a circular table, صح? And I have 4 seats. Let's call them, this is seat 1, this is seat 2, this is seat 3, and this is seat 4. طيب. هلا, in order to seat 4 people on this table, can anybody now tell me how many ways do we have? 4 factorial. ليش 4 factorial? Because I have 4 people to place in the first chair, صح? And then after the first was actually seated, now I have 3, صح?
3, yes.
And then in the third, after I seat 2, I have only 2, and then I have the last one. So it's basically 4 times 3 times 2 times 1, right? So therefore, what should I say? For a table with 4 seats, there are 4 times 3 times 2 times 1 ways to seat 4 people. Now this is using which rule? Using the product rule. Using the product rule. Right. Now what does it say? It says that 2 seatings are equal, are considered the same, if in the 2 seatings for each person sitting, he has the same right neighbor and the same left neighbor. So let me ask you the following. Can anybody give me another seating on this table which is equivalent to this seating اللي هو 1 2 3 4 where every person has exactly the same right neighbor and the same left neighbor?
1 and 3.
Huh?
3 has the same.
طيب, so you okay.
Change 3 with 1.
طيب, so you put 1 here. طيب. وبعدين where do you want to put the 2?
Place of 4.
In place of 4 here with a 3.
The other side, opposite of 1.
The opposite you mean this one.
Yes.
And then 4. Now, do you see that, for example, here, number 2, who's on his right?
1.
On his right is 1, and on his left is 3, صح? طيب, is this the same here?
Yes.
Well, on his right is 1, and on his left is a 3. طيب, do we have any other seating which is also the same as this one? Yes.
You can do it 4 times.
Huh?
You can do it 4 times.
How?
Clockwise, you go clockwise with all of them.
So he says you can do it 4 times because we can. Do you notice that this is basically a rotation?
Yes.
It's basically a rotation, صح? So let's do another rotation. Let's see, for example, since we have 3 here, let's have 2, okay? So if we have 2 here, we're going to have 3 where? We're going to have 3 here, صح? We're going to have 4 here, and we're going to have 1 here, صح? طيب, what else do we have?
1 in the place of 3.
1 in place of 3, basically here, صح?
Yes.
1 and then 2, صح?
Yes.
And then 3 and then 4. Do we have any other? So as you can see here, for an arbitrary seating, 1, 2, 3, 4, I was able to generate another 3, صح? So, and this is arbitrary. So this means that for any seating, among these n seats, or these n factorial seats, okay, we will always have 4 that are exactly the same, or they are considered the same. So in total, how many do we have? Well, now we apply the division rule. Since we have 24, and among those 24, I will always have 4 that are the same, then what am I going to have? I'm going to have 24 divided by 4.
Where did you get to 24 from?
I had a 24. 4 times 3 times 2 times 1. We got it in the beginning. Okay? We got it in the beginning. So therefore, since each seating corresponds to 4 seatings among the 4 times 3 times 2 times 1, which is equal to 4 factorial seatings, and using the division rule, we conclude there are 24 divided by 4, which is equal to 6 different seatings where left and right neighbors differ. صح ولا لا؟ we will have 6. واضح يا شباب الديفيجن رول؟ Any question? Yes.
We found the 4. How did what are the the two left that we didn't find. Find four combinations now.
طيب.
The other two.
What do you mean? Which other two?
You said 6 different settings.
6. Well, why 6? Because we have 24 divided by 4. Because we have 4 seatings that are exactly the same. So 24 divided by 4, so we have 6. Now, if you want to list those 6, you can go ahead and do that. You just need to make sure that each one of them, you have at least one person has a different, right neighbor or left neighbor.
ليش ما نقصنا طيب؟
ايش يعني نقصنا؟
نقص احتمالات انه كل واحد يمينه نفس اليسار نقص احتمالاتهم.
كيف؟ اعطيني احتمالاتهم طيب اول شيء. ايش الاحتمالات
24
ال 24 ايوه. طيب.
واطرح منها اللي لما يصير اليمين نفس اليسار اللي الروتيشن.
ترى اليمين نفس اليسار. تطرح منها 4. انت لما بتطرح منها 4
اطرح الواحد. يصير تطرح الواحد اذا طرحت 4. صح؟ مثلا الحين اطرح 2 يقدر يصير يمين وتحت ويسار وفوق.
الاثنين
يقدر يصير تحت.
yes 2 can be yes. طيب.
وثلاثة نفس الكلام واربعة نفس الكلام.
No, but wait a minute. They have to go all in the same seating. You cannot. It's the same left and right neighbor for all of them. That's why when you are moving 2, you're not only moving 2, you're not rotating 2, you're rotating 2 with 3 with 4 with 1. And there is no other rotations. There are no other seatings in which all of them have the same right and left neighbor. Okay? So each 4 correspond to one way. You have 24. 24 divided by 4 is 6. Okay? طيب. Okay, so let's now do the last thing, which is 3 diagrams in this section before we take our activity, right? The last thing that we will do is the activity. طيب. So a branch in a rooted tree will correspond to a choice emanating from that root. The way we are going to use the trees is as follows. We are going to build a tree such that whenever I go from one node, when I look at the children are nothing but all the possibilities, okay? All the possibilities of whatever, okay? Of whatever. So what is that whatever? Well, let's look at the first example, and let's see how we can apply a tree, to solve counting problems. Now, what does the example say? How many bit strings of length 4 do not have 2 consecutive ones? How many bit strings of length 4 do not have 2 consecutive ones? So let me start with the root. This is my root. Okay? Yes.
What does it mean, consecutive?
Consecutive. ايش يعني consecutive؟ يعني جنب بعض. يعني we need to count the number of bit strings of length 4 that do not have 2 ones next to each other. Yes.
Do we see? We have only 3 possibilities of having ones next to each other, which is the first bit and the second bit and the third bit, the third bit and the fourth bit.
طيب.
So do we take the maximum possibility, which is 2 to the power of 4,
طيب.
minus the 2 to the power of 2,
طيب.
and the same 3 times.
So what's your answer?
2 to the power of 4 minus 2 to the power of 2, multiplied by 3. So 12.
12?
Yes.
طيب, let's see whether it is 12 ولا لا. Okay? طيب. Okay. So if I want to use a tree, what will be what will be the children of this root? What do they represent? 0 or 1, صح? So they will represent either 0 or let me put the 0 next to it. Either 0 or 1. طيب. What about the next one? So this is 0, This is 1. طيب, the next one, you said it's gonna be ايش? Also, it's gonna be 0 or 1, right? 0, 1, 0, 1. So, what does this 0, 1 at this level? What does it mean?
2 bit? 1 bit. 1 bit.
Which one bit?
The first bit.
The first bit, صح? So this represents actually the first bit. And at this level, it represents ايش?
The first 2 bits.
The second bit, صح? It represents the second bit. Now, based on what we have done so far, do we have 2 bits, 2 consecutive ones? Where are they? The last one, صح? طيب, and I'm counting the bit strings of length 4 that do not have 2 consecutive ones. Do I have to continue my tree in this branch? No, I don't, صح? In fact, what I can do is I can do something like this. خلاص, because I already have two ones. Okay? I already have 2 ones. طيب. Now, let's continue because I have 4 bits, right? Now these 2, so let's go to the third bit. What are the possibilities of the third bit? Well, here, again, it's gonna be 0 or 1. Here also it's gonna be 0 or 1. Here it's gonna be 0 or 1. And of course here there is nothing because we are finished. We are done. So this is the third bit. Do we have 2 consecutive ones?
Yes.
Where are they?
The last 1, 1. The one in the middle.
The one in the middle, صح? When you have 0, 1, 1. So here I will not continue, right? I'm not going to continue here. طيب. Then I need to go one more, صح? So okay, so 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Yalla, do I have any 2 consecutive
Yes.
bits? Where are they?
On the right side.
Well, I have this one, صح? And 0, 0, 1, 1, basically this one. Anything else?
No.
طيب. So now, if I want to count all bit strings of length 4 that do not have 2 consecutive zeros, what should I count? The leaves. Any leaves? ولا leaves in the last level without an X? Leaves in the last level without an X. What are the leaves in the last level without an X? 1, 2, 3, 4, 5, 6, 7, 8. So you made an overcount. Trees are not bad. Okay? So therefore, we have 8 bit strings of length 4 that do not have two consecutive zeros. That do not have 2 consecutive zeros. Okay? Right, let me ask you the following question. You know, when I reach the second bit here, I know that the first 2 bits are consecutive ones, صح? طيب, do we know how many bit strings exist underneath this node?
Yes,
How many?
it's the same as the bit string that's next to it.
2 to the power of the depth.
2 to the power,
The depth from that node.
which is?
4.
To the power 2, صح?
Two.
To the power 2. Why? See here, the first two bits are ايش؟ Are 1 1, صح? So below, what do you have? You're gonna have 1 1 x x, صح ولا لا؟ x x ايش ال x x؟ 2 by 2, right? 2 square. So this is basically just in case, instead of the question asking how many bit strings of length 4 that do not contain two consecutive ones, if the question was how many bit strings of length 4 do contain two consecutive ones. Okay? In this case, again, when you reach this 1 1, you really don't have to continue. خلاص, you already know how many bit strings do you have here that satisfy or they have in 1 1. So whenever you reach a 1 1, you don't need again to continue. Just make sure you get the number of bit strings below this node. Okay, below this node. Right. This is the last example. A playoff between two teams consists of at most 5 games. How many of you are interested in basketball and watching the NBA basketball? Do you watch? So do you know what's a playoff?
البلاي اوف اتوقع بداية السيزون.
ها؟
بداية السيزون
بداية السيزون لا حرام عليك.
What's the result?
أو نهاية السيزون.
حرام عليك هذه نهاية السيزون.
نهاية السيزون.
هذه after you finish the schedule of games, the scheduled games between every two teams in a certain region, what they do is they will qualify, for example, I don't know how many teams they qualify from each region, 2 teams or 4 teams, I'm not sure, okay? And then what they will do is the teams between the different regions, they will start playing these playoffs. ايش هم البلاyoffs? For example, in soccer, when you reach, for example, the 16 or the 8, usually, how does it work? Well, it's either one match, صح?
Yeah.
Or it's 2 matches and they will somehow add the results and, if there is a draw, at the end of the second match, they will go to penalties, صح? هنا لا. هنا what they do is they play at most 5 games. The team that wins the first 3 games is the winner. The team that wins the first 3 games is the winner. Now, in basketball, there are no penalties. Okay? How do they, if there is a draw, what do they do? Well, they basically, extend 5 minutes. Every time they extend 5 minutes until at the end of one of those 5 minutes, if one of the teams has more points than the other, then the game starts. Okay? So basically, what is the question here? Well, the question says, well, in how many different ways can the playoff occur? In how many different ways can that? For example, if the first team wins the first 3 games, do we continue?
No.
خلاص. He wins the first, so basically it was only 3 games. طيب, when do we have a 4th game?
2-2.
If each team wins at least 1 game, صح?
Yeah.
If each team wins at least 1 game, then we have either 2-1 or 1-2, right?
Yes.
So now we need
Okay.
another game. Okay? So basically what we'd like to do is we'd like to see, well, in how many different scenarios do we have? How many different scenarios do we have? So again, what we're going to do is we are going to use the tree diagram. So let us start from the root. And now, what will be my branches? Huh?
We can use 1 and 0.
Wins. Team 1 and team 2.
Wins or road?
Team 1 and Team 2. What does it represent? Team 1 or Team 2?
Team 1
Team
wins.
one.
Team 1 wins
Team 2.
or
Team 2.
Team 2 wins.
Yes.
Either Team 1 wins or Team 2 wins. That's why what I'm going to do here is I'm going to say 2 teams, T1 and T2. And here I'm going to start by saying, well, this is T1 and this is T2. So on the left, T1 has 1 and on the right, T2 has 1. And then I proceed. Okay? Right. So what does this level represent? The result of game 1, صح?
Yes.
So this is first game result, right? Let's just put it first game. So this is the first game result that team 1 wins or team 2 wins. طيب. Now let's go to the second game, right? طيب. So again, what are the possibilities? Well, we only have either team 1 wins or team 2 wins. And similarly here, we can have team 1 wins or team 2 wins. Okay? Team 1 wins or team 2 wins. طيب. So this is basically the second game. Do you think we have a winner by this time? Why not?
Maximum.
Because we need to win 3, صح? And we only played 2. There is no way that the playoff is finished. So let's go one more game. So now we will go to, let me make it shorter so that I have some time to write in the end. Okay, so this is T1, T2, T1, T2, T1, T2. Okay, so T1, T2, T1, T2, T1, T2, T1, T2. This is the third game. Okay, this is the third game. طيب, do I have winners here?
Yes.
Where are they? The most right, the most left branch and the most right branch, صح? So we have T1, T1, T1. T1 has won 3 games in this scenario. So this is basically done, صح? And in the second scenario, basically T2, T2, T2 won the 3 games. So this is the second scenario. Okay? So these are basically done. The rest, we still have, it's basically 2-1, صح? One of them is 2-1 for T1, one of them is 2-1 for T2. So now we need a 4th game for these, right? So I don't need to continue my tree here. I do not need to continue my tree here. All what I need is continue my trees here, صح? Okay, so this is T1, T2, T1, T2, T1, T2, T1, T2, T1, T2, and T1, T2. So this is our 4th. This is our 4th game. Do we have teams that have won 3 games? Yes. Well, let's start from the right, صح? So we have T1, T1, T2, T1, صح? So T1 1. طبعا T1, T1, T2, T2 still draw. طيب T1, T2, T1, T1. So this is also a win, right? طيب T1, T2, T1, T2, 2-2. T1, T2, T2, T1, again 2-2. T1, T2, T2, T2. Now this is a winner, right? And similarly here, T2, T1, T1, T1. So this is a winner. T2, T1, T1, T2, no. T2, T1, T2, T1, no. T2, T1, T2, and T2. So this is again a winner. طيب T2, T2, T1, T1, no winner. T2, T2, T1, T2, I have a winner. Okay? طيب. So now all nodes that have another circle around them are basically finished games, right? What am I left with? I'm left with these, right? طيب, what will happen with these?
Still have a game. One will draw.
You have one more game.
Or one,
I'll have one more game. Am I going to check anything here ولا things are finished? Well, here things are finished, صح? Because it's already 2-2, right? It's already 2-2. So basically, whoever wins the fifth wins the whole playoffs. Wins the whole playoffs. So basically, I have also these. All these are winners. So now, if I want to count, how many scenarios do I have? What do I need to count? I just need to count. Basically, I forgot this one.
اخر واحده اليمين قبل ما في
This one, صح? Okay. So basically all leaves, right? All leaves. So in the third game, I have 2. In the fourth, I have 3, 4, 5, 6, 7, 8. And here I have 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the playoffs, therefore, the playoffs can occur in 20 different scenarios. In 20 different scenarios. واضح يا شباب؟ Any question? Any question? طيب. Okay, so this is basically the end of this section. Now, before moving on to the next section, what I would really like to do is I would like to do an activity, okay? The bad news is I do not have papers. I didn't manage to copy them. But at least for your section, if you go to Gradescope and go to Activity 11, you can actually download the PDF file, okay? If you want, you can write on it and then upload it again. If you want to write now on a piece of paper, solve, and then, scan and submit, you can do whatever you want. Now, what I will do is the following. Let me, of course, you have the notes with you, right? Let me show you the activity. So basically the activity consists of 1, 2, 3, 4, 5 questions, right? How many bit strings of length 12 either begin or end with a 0, 1? How many different 3-letter initials, meaning in English, with none of these letters repeated can people have? Like for example, like my name is Wasfi Hassan Khatib, so Wasfi Hassan Khatib, WGK. So these are my initials. By the way, in the States, for example, or in Europe, whenever you write a contract, sometimes there are so many places where you have to sign. Huh? They don't let you make your own, the whole signature in all these places. What you do is you just write your initials. You just write your initials in those places, and then you have to sign maybe the last page or the last paper, which has the biggest space for you to sign. That's how they do it. But these are 2 questions that are easy, right? Now, next we have this question. How many positive integers less than 1,000 are divisible by 7, divisible by both 7 and 11, and finally divisible by 7, but not 11. Okay? So what we will do is, together, we will solve number 1, number 2, with 3A, with 3B. Okay? And I will leave you with 3C to, figure it out and submit it. And make sure you submit the activity, because if you don't, then you are absent. No exceptions.
individual or
No exceptions. No, it's not individual. It's groups. You can do it in groups of 2, or at most groups of 3. Okay? You can do it in groups of 2, or at most 3. I will give you. It's now 1:38. Let me give you like 7 minutes, okay? I'll give you 7 minutes, and then we will try to solve them together, okay?
7 minutes to solve one.
To solve all of them. Try to solve all of them, okay? Try to solve all of them, and then we will solve together all except one.
طيب ما اقدر احلها كلها. ما فهمت قصدي ما ينفع كمان خلاص. طيب هو بيحلها كامله وتبقى سي هذا اللي اتكلم عنه. اوكي انا يعني بالحالة
لا تعالوا ثلاثة.
لا الله
You can be 3 يا شباب. نعم. تحاولوا تحلوهم كلهم، بس أنا راح أحل معاكم لغاية بس تحاولوا تحلوهم كلهم. Try to solve all of them. لا ممكن تعال معي. حل حالك my cup of tea.
كل شيء ما عدا 7 ويقول لك هذه
لو كان
لا بس هو تقدر
شوف انا وش يس عشان تشوف مثلا ما انتبه
نقدر نستفاد
اتوقع لا اوكي نرجع بعدين
شوف ايوه انت عندك اول شيء 1 وباقي كل بس عندك شوف 1 0 1
ليش
عندنا اول شيء لما كانت كلها زيرو كلها اخذ بالتالي لازم تكون هي واحد بعدها وين تكون صفر واحد او صفر واحد راح نشيل الجزء الاول بس نشيل جزء واحد منها لا بس أنا عشان فنحن هذه كلها هذه بنص بعدين هذه نص النص 0 1 هذه تقسيم مرة طلعنا اللي هي 0 1
ايش يعني نقسم هذه كلها؟
هذا عشان تطلع تنتهي ب 0 1 ايوه بس هذا 0 1 لازم نطرح كمان اتوقع انت مسوي تقسيم 4 تقسيم 4 كل زين 7 دائما نشوف على 4 بس نشوف عندنا 1 2 3 دائما واحده منها تطلع لنا تقسيم 4 برضه هذا يحضر لنا تبدا هذا بس اكيد في شيء لازم نطلعه
نقسم 4 جي؟
لا 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 يا جماعة ايوه بعدين تنتهي واللي تبدا بعدين نطرح المشترك اللي هو توقع بس واحد
ايه صار لنا مو
قصة تدفع
حيكون بيصير
كم 7 كم
يعني تدفع تدوري
اسمه واحد اللي تبدا كامل لما نطرح مره واحده المشترك زي الاول 12 هي A اور B ايش تساوي؟ تساوي A بلس B ناقص A تساوي
اوكي صرت
I think you should be ready, صح؟ Okay. يلا يا شباب. How many bit strings of length 12 either begin or end with a 0, 1? Go ahead.
2 to the power 12 over 4 2 to the power 10
So basically 2 to the power
10
2 to the power 10 أيوة.
plus 2 to the power 10
2 to the power 10 plus 2 to the power 10
minus 2 to the power 8
minus 2 to the power 8. واحنا we did this صح؟
صح؟
اللي هي yes this is for the one that starts with a 0, 1, right? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, this one ends with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this one is basically the overcount, صح؟ اللي هو 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we remove the overcount. طيب, what about this one? 26 multiplied by 25 multiplied by 24. طيب, what if the three letters can be repeated? 26 times 26 times 26. It will be 26 cubes, صح? طيب, let's go to this nice question. How many positive integers less than 1,000 are divisible by 7? Yes.
Well, you divide 1,000 by 7,
أيوة.
and then if you ignore the remainder, that's the value. So it's 142.
Not the remainder. You mean the division?
Yeah, you ignore the remainder.
So basically, it's the floor of 1,000 divided by 7?
Yeah.
طيب. It's not. It's the floor of 999 divided by 7. Now let me explain this why, and then I will go to the second one. Okay?
You said less than not
What do we have here? By the way, in these questions, it's good to go with the small numbers. طيب. First of all, 0, is it included?
No.
So 0 is not included. Huh? Right. Let's choose a small number, 30. If we choose 30, how many divisible by 7 less than 30? 4. صح? 4. طيب, what if I said 28? How many less than 28 are divisible by 7? 3, move 4, صح? So that's why we should start from, because it says here less than. Because here it says less than. So that's why it is the floor of 999 divided by 7. طيب, مين يعطيني البي؟ Yes. عادي بس أهم شيء إنه حدا إيه. Yeah. By midnight. Yes, go ahead.
Just divided by 77.
Just divide by 77. Okay, so this is 999 divided by 77, right? Divided by 77. Why divided by 77? Because it is by both 7 and 11, صح? What if it was by 7 or 11? What will be the value? Add and then? So 999 divided by 7, floor, plus 999 divided by 11 minus this number. صح? Minus this number. Exactly the same as, question number 1. طيب. Okay. Do you know what will happen if the 7 and 11 had common factors? Like if I asked you between 6 and 10, how many are divisible by both 6 and 10? What will the answer be? Is it 999 divided by 60?
No. It's 999 divisible by 7 minus 999 divisible by 11.
No, I said 6 or 10.
Oh.
6 and 10.
Oh.
6 and 10.
999 divisible by 7.
And less than 1,000.
Minus
And less than 1,000.
same, but 6 and 10.
Same thing. It should be.
Because 6 and 10, they have common factor.
What's the common?
6
Two.
multiplied by 5.
2. What is the least common multiple between them? 30. صح? 30 is the least common multiple between them. This is the smallest number that is divisible by both 6 and 10. So it will be 999, the floor of 999 divided by, okay? And of course, C is for you. Inshallah, we'll see you day after soon. For question 2? هلا خليني بس اسكر
وين شوف